Well, hey everybody, Mr. Reeves back with you. And in this video, we're going to be looking at some of the properties of equality. So on the screen in front of you, I have a table that gives several of these properties. Real quickly, the reflexive property says, seems kind of obvious, that everything is equal to itself. So A is equal to A. The symmetric property says that if A is equal to B, then B is equal to A. This is kind of a useful one when you just want to simply rewrite the order of an equation. You simply put what was second first and what was first second. The transitive property says, hey, if A is equal to B and B is equal to C, then A is also equal to C. Can you see how the first one jumps to the last one and the two middle ones are the same? And the substitution property down at the bottom says, hey, if A is equal to B, then anywhere you see A, you can replace it with B, and anywhere you see B, you can replace it with A. All right, but we're not going to be focusing on those properties. We're going to be focusing on these ones right here, the addition, subtraction, multiplication, and division properties. And the reason that we're going to be focusing on these properties right here is these, not including transitive, these are the properties that are going to help us to solve equations. All right, so we are going to be solving equations. That's our next several lessons. And these properties are what we use to solve an equation. So this first one, the addition property of equality, says that if A is equal to B, then A plus C is equal to B plus C. So for example, if I had 3 plus 2 is equal to 5, I hope you agree that that is a true equation. If I were then to add 4 to both sides of that equation, what would I get? Well, I would get 3 plus 2 plus 4 is equal to 5 plus 4. And of course, 3 plus 2 plus 4 is 9, and 5 plus 4 is 9. So the addition property of equality says if you start with the true equation, if you add the same thing to both sides, it's still a true equation. All right, subtraction property is very similar, except instead of adding, we are subtracting. So if I had 12 minus 4 is equal to 8, all right, that is a true equation. Hopefully you would agree. If I then went ahead and subtracted 3 from both sides, what would I have? I would have 12 minus 4 minus 3 is equal to 8 minus 3. Well, again, 12 minus 4 is 8. 8 minus 3 is 5. And of course, 8 minus 3 is 5. By the way, these numerical examples don't prove it's true. I'm simply showing you an example of it working. And of course, multiplication and division is going to be the very same idea, right? If we start off with an equation, all right, again, A is equal to B. All right, I'm going to go back to my original one, which was 2 plus 3 equals 5, right? Only this time, I'm going to multiply both sides by 4. All right, so I'm going to have 4 times 2 plus 3 equals 4 times 5. All right, well, 4 times 2 plus 3, that's 4 times 5, that's 20, and that's equal to 20. So we started off with a true equation. We multiplied both sides by the same thing, and we got another true equation. Of course, division is going to work the same way, although with division we have to be careful, and they did not include it here. We cannot divide by 0. Okay, so whatever you're dividing by both sides by, you have to make sure it's not equal to 0. Okay, so again, if I had 5 plus 3 equals 8, there's my true equation, and then I go ahead and I divide both sides by 2. What do I get? Well, 5 plus 3 is 8. 8 divided by 2 is 4, and I get 4 equals 4. So we can do this, but we got to make sure we don't divide by 0. All right, so what these properties of equality allow us to do is they allow us to solve an equation, right? So if I have x plus 4 is equal to 10, and I want to know what x is, well, if I can subtract 4 from both sides, I can get that x by itself. It's called isolating the variable, right? And I know I can do this because the subtraction property of equality says as long as you subtract the same thing from both sides that are already equal, they will stay equal. So my equation changes. Both sides are now 4 smaller, but I have an equivalent. I have an equation that is not equivalent, but it is still true. And I get 10 minus 4 is 6. So that gives me the answer to the equation, x is 6. And of course, we could check that. 6 plus 4 is equal to 10. So we use inverse operations on both sides. If they have subtraction, we add. If they have addition, we subtract. If they have multiplication, we divide. And if they have division, we multiply. And as long as we do the same thing to both sides, we are applying these properties of equality here. So we know that if our original equation was true, then our new equation will also be true, and that will lead us to the value of the variable that we need. Okay? All right, so let's go ahead and jump over to some of the IXL problems that will apply these properties, and let's see if we can be successful on solving some of these. So it says if negative 17 minus t is equal to s, then negative 17 minus t times negative 32 equals s times negative 32. So what did they do to get from that top equation to that bottom equation? They multiplied both sides by the same number. Do you see that? They multiplied both sides by, let me see if I can get the highlighter here. That's what I'm going for. They multiplied both sides by negative 32. And since they multiplied, that's going to be the multiplication property of equality. All right? If we take a look at this next one, what did they do to get from their original equation to their new equation? Well, there it is. They added z to both sides. So that is the addition property of equality. All right, take a look at this one. What did they do on this one? Again, the difference between the top equation and the bottom equation is that 92 that is added at the top. So that also is going to be the addition property of equality. All right, let's skip up to the next level and see what they have for us there. All right, again, compare your original equation to the one underneath, and what did they do? They divided both sides by negative 82. That's our division property of equality. All right, one last one here. What did they do? They had our original equation. They multiplied both sides by the number 69. That would be the multiplication property of equality. All right, so again, these are different properties of equality. All of them are true. All of them are always true for any equation. We're focusing on these four for solving equations. These ones are also very useful to know, and you will have applications of these later on in math. All right, until next time, have a great day.